We are now getting very close to the end of the semester. We are down to the last two topics. They are both theorems that you interacted a lot with back in Calculus 1. And the first one is called the extreme value theorem. So before I get into the extreme value theorem, I'm going to talk about how the videos and the in-class activities for the next two sections are organized because we're treating those a little bit differently this time. After that, we're going to motivate the extreme value theorem with some memories from calculus. We will state the extreme value theorem, and then we'll list some of the issues that we must address to prove the theorem, and then take care of the rest in the next video. So just to give you an idea about how the videos are going to be organized, we're going to introduce the intuition and understanding around the theorem generally. We're going to state the theorem, and then give you some time to work on the in-class activities related to the strategy of the proof. But before we make you do that, we'll give you some idea of what the issues are so that you have a little roadmap of where to go. And then we'll come back with another video to actually explain the proof. All right, so remember from your calculus days how we used to find maxima and minima, right? When you were doing those optimization problems. So you would want to find out where the highest and lowest values of your function are. So one place to find those were the critical points, right? That is where f prime of x equals 0. And then you would find where f prime of x does not exist. And then you would make sure to check the endpoints. And the idea is if you had extreme values, maximum or minimum, those are the places where you would find them. However, and the maximum was the highest of those values, and the minimum was the lowest of those values. However, there was an underlying question that may not have been made super clear. How do we know that there's a maximum or minimum at all? Right? We know that if there is a maximum, it's one of those points. If there is a minimum, it's one of those points. But how do we know one of those points is actually going to be the maximum or the minimum? And the reason we know is something called the extreme value theorem. So if you have a continuous function f from the closed interval ab to the real numbers, then that function has both a maximum and a minimum value. And what we mean by a maximum and minimum value is there are two numbers, c and d, in the domain where every output of the function is greater than or equal to f of c and less than or equal to f of d. So in order to prove this theorem, there are two issues that we have to resolve. It's kind of nice that there are only two, but they each have their own challenges. So first of all, we have to ask the question, is it possible for f to be unbounded? All we know about f is it's continuous and the domain is a closed interval. What's keeping the function from being unbounded? Right? Because if it was unbounded, that would eliminate the possibility of either a maximum value or maybe a minimum value, or who knows, maybe both, right? So we have to eliminate the possibility that f is unbounded. Once we have that, if f is bounded, then we know the range has both a supremum and an infimum, but now the issue is, what if either the supremum or the infimum is not in the range? That would keep us from having a maximum or minimum value as well. So you're going to have to deal with those between this video and the next one. And to do that, all you have to do is click on the link below this video.